Is the practical file of BPHCL134. The course code is BPHCL134 and it is the practical of BSCG first year. So today I will see you all the experiments one by one. So just take the screenshot or download the video, share the video with your friends and prepare your practical file. I will try to maintain the quality of the video just for there is no problem to you to prepare your notes and the practical file. The object of first practical is to verify the Thevenin's and Norton's theorem. It is experiment you have to perform in your practical lab. First of all, and the experiment number 2 to verification of superposition and maximum power transfer theorems. First of all, you have to understand and you have to read the book, read the topic related the experiments, and you have to go on your college in your practical lab where all the kids, all the instruments, apparatus are available by which you can perform the experiment very well. After it, read your or note all the readings carefully. So the experiment number 3 to study of IV characteristics of a PN junction diode. In this experiment, you have to make a circuit diagram in your kit, connect all the connections very carefully. You have to measure the output current for varying in forward voltage, and you have to plot a graph. By graph you can calculate the knee voltage, and by slope you can calculate the forward resistance, and you have to also find a slope and you find the reverse resistance, and you observe the forward resistance is less, or we can say the reverse resistance is more than the forward resistance, because in reverse bias very measure or very minor current flow, but in forward resistance plenty of current flows. So you can see the forward resistance is 430 ohm and the reverse resistance is 8 into 8.3 into 10 to power 4 ohm, and the knee voltage is 0.64 volt. Next, experiment number 4 to study the operation of half wave and full wave rectifier with filter and without filter to find the ripple factor and efficiency. It is the circuit diagram of our half wave and full wave rectifier. First of all, you have to take all the readings of half wave rectifier without filter, and after it half wave rectifier with inductor, after it half wave rectifier with L section, and the other, that is the half wave rectifier with pi filter. Similarly, you have to also take all the values, all the readings from the full wave rectifier with without filter, and full wave rectifier with inductor, and also the full wave rectifier with L section and pi section. And you have to calculate the mean values of ripple factor and also the efficiency. The formula of ripple factor is the R is equal to R gamma. Gamma is equal to VDC upon VSC. VDC means the measured DC voltage, and the VAC is the measured AC voltage by multimeter. Multimeter is the device by which you can measure all the values, all the different types of values like resistors, voltage, AC voltage, DC voltage, also diode, also the check the continuity of the wire. And the next experiment is the use of multimeter for measuring resistance, AC and DC, and continuity of wire. So as we also explained the measure of the resistance here, BBEROY, GBV, GW. Measurement of DC voltage and measurement of AC voltage. Testing of wire with continuity, and also note the precautions. Next experiment is the study of LCR circuit. L stands for inductor, that is the inductor, or C means capacitor, R means resistors. So the formula of resonant frequency is the FR is equal to 1 upon 2 pi under root LC. Here it is the graph that is called the semi-logarithm graph. You can take simple graph is not sufficient to draw this graph, because here you can see the frequency range is start 100 to 1000 means 1000, 10,000, and also in the last is 10,100,000 means 1 lakh. So it is the graph of this experiment. And next here you can see the resonance frequency is the 5kH2. The quality factor you can also find the formula Q is equal to FR upon del F. Here is the FH and FL. FH is the higher frequency and FL is the lower frequency. Here Fk means the resonant frequency and FL is the lower frequency and FH is the higher frequency. And next the result and also the precautions. And the last experiment is the to determine the resistance per unit length of the Carey Foster bridge wire and the value of an unknown low resistance. Carey Foster bridge is the such type of bridge which works on the principle of Wheatstone bridge. Wheatstone bridge is the experiment that which you can calculate the one unknown resistance by giving the three known resistance. P upon Q is equal to R upon S. So that is the observation table of Carey Foster bridge. The resistivity is equal to A means area is equal to pi r square and multiply R y upon L. Y is the resistance of the wire, and L is the length of the wire, and R is equal to a radius of the wire. And the last, you can see the result and precautions. So in comment box, share your feedback related to this video. Okay, thank you. Jai Hind.